All right. A two-sample t-test is used to test the difference between two population means, mu1 and mu2, when sigma 1 and sigma 2 are unknown. What does that mean, guys? It means S1 and S2 are given instead. It has to give you standard deviation. The samples are random, just same condition as previous one. The samples are independent, and the population are normally distributed, or the sample size must be at least 30. It's the same condition. So the only difference, guys, in number one, in the previous one, we did two sample z-test because sigma 1, sigma 2 were unknown. Now we're gonna do a two sample t-test because sigma 1 and sigma 2 are unknown. Okay. The two sample t-test for the difference between means is small independent samples. Verify that sigma 2 and sigma 1 are unknown, which is going to be obvious in the problem. The samples are random, they are independent, and either the population are normally distributed or the sample size is at least 30. Repetition, guys. State HO and HJ, that could help for today's test. Calculate the standardized test statistic. You see, I didn't call it Z this time. I call it T because we're doing a t-test. Find the p-value, make a decision to reject or fail to reject the null hypothesis, and interpret the decision in the context of the original claim. To state the null in the alternative hypothesis, guys, you have three choices, no others. This is the first one. And you guys agree with me that this is the second one? And who would like to give me the third one? Always start with 1 and then 2. Don't mix them up. 1 and 2. So what would be the sign right here? Greater than or equal to? Yeah. We use red. Unless. Just pick one of the three, guys. That's it. It's the same as the previous section. I'll come to this in a second. We're gonna need this. That's very, very important. And that's what you mentioned, Abe. It's asking you for pooled. What do you put, yes or no? So you're gonna get the answer right now. Okay, there's the problem. The results of a state mathematics test for a random sample of students taught by two different teachers at the same school are shown below. Do you guys agree that the samples are independent because it says two different teachers and two different groups of students? So it is independent samples. Can you conclude that there is a difference in the mean mathematics test scores for the students of the two teachers? Use alpha equals 0.10. Assume that the population are normally distributed and the population variances are not equal. Okay, let's see if the conditions of the test are met. Sigma 1 and sigma 2 are unknown, guys. He gives us S1 and S2 instead. He says random samples, so the samples are random. Let's see. They are independent. Yes, two different teachers, two different groups.
They're not normally distributed,
normally distributed. Yes?
They are not normally distributed.
No, they are.
I thought because they're under 30 though.
No, but once the population the population is bell-shaped, that's good enough. We don't care about the sample size. If he doesn't say that the population are normally distributed, then you must require a sample size to be bigger than 30. But once he says, assume that the population are normally distributed, you met the condition, because look what the condition says. The population are either normally distributed or the sample size bigger than 30, not necessarily both. When I ask you to solve problem 8 or problem 9, you don't have to do both. If you do 8, you're good. If you do 9, you're good, but not both, not necessarily both. Okay, so the conditions of the test are met. Eventually, guys, you might not be asked to verify the conditions of the test, because once he asks you to test the hypothesis, that means he's assuming that the conditions of the test are met. Just go to step number 1 and state HO and HA. So, can you conclude that there is a difference in the mean mathematics test scores? Would you guys agree with me that it's going to be this, number 1, difference right here? So it will be HO, HA, mu1 equals mu2, mu1 not equals to mu2, and that's the claim. And this is going to be, guys, a 2-sample t-test. And why? Because he gives you S1 and S2. If you just want me to put a Y here, S1, S2 are giving instead of sigma 1, sigma 2. Just keep that as a note highlighted. That's very important note right here. All right. Let's go to the 2-sample t-test and see how we're going to proceed from there. I'm just going to take time here because slightly different from the previous test. It's number 4, guys. Okay. He's asking for x1 bar, not sigma 1 right away. We already have it, which is what? Oh, sorry, there are no dollar sign here. These are scores, guys. I'm sorry. Shouldn't have put dollar signs here. So 473. He wants S1. You see, now it says S1, not sigma 1, because it's a t-test, 39.7. You see, the sample size is small. Usually when you do a t-test, you do it with a smaller sample size. 8. X2 bar, which is, that should be an X1 bar and X2 bar. X2 bar is 459. S2 is 24.5. And N2 is 18. And now that's important. Okay, now the alternative sign, you guys agree with me, it's different from Y right here. And now pooled, do I choose yes or no? Let me show you how to decide on the pooled. So I'm going to just put this on the side for a second. If he mentioned in the problem that the population variances are equal, pooled is yes. If he mentioned in the problem that we assume that the population variances or population standard deviation are not equal, then pooled is no. So select pooled yes if the population variances are equal, and select pooled no if the population variances are not equal. So what is it going to be in our case, guys? Yes or no?
No.
It's a no. Exactly. Enter. It will give you totally different results, guys, if you mix up the no and the yes. It will always give you the hint. If he doesn't give you any information about population variances, it's by default should be always a no. But I think this book always identify whether it tells you whether you want to use a no or yes. Okay, and then scroll down, guys. There's an arrow, and then okay, this is a 2-tailed test. So if I hit calculate, watch what happened. Oh, T is 0.92, and look at the p-value is 0.3792. T is usually 3 decimal places, so I have 0.922. P-value is 0.3792. And I'm done with the calculator. That's all I need. Okay, what's the decision? What's number 4, guys? Now this is a review for chapter 7.
Fail to reject.
Fail to reject. I know you're gonna notice everything we did today is failed to reject HO. It wasn't intentional. I just put the problems there and turns out to be there. So because p-value is more than alpha. And then conclusion, guys.
There's not enough evidence to support.
Exactly. There is not, you're picking it up right now. There's not enough evidence at the, whatever the level of significance is, 0.10 level of significance. And that should prove to you guys what I said is right about continuation. We're just doing the same thing, step 4 and 5, just like we did it in previous chapter, to support the claim that, I'm gonna write it down, there is a difference. We're not saying we're supporting the claim. We're saying, guys, we don't have enough evidence to support it. That means the claim probably is wrong. We say there is not enough evidence. Don't forget the word not. To support the claim that there is a difference in the mean math test scores for the students of the two teachers. So probably they're doing very much the same on average. That's what this problem says. Okay, so here's the next question. A manufacturer claims that the call-in range in feet of its 2.4 gigahertz cordless telephone is greater than that of its leading competitor. Probably I should get rid of the question because nobody uses those 2.4 cordless phones anymore. So what I'll test which hypothesis will I use, guys, from the first sentence? What is it gonna be? First, second, or third? It says they claim that their call-in range is greater than that of their competitor.
Third.
Any other answers? So I have a student said this one. It says greater than.
The second.
Second. Do you agree it should be the second because greater means this sign? mu1 is greater than mu2. Remember, when I say greater, I'm not putting the equal sign next to it. It can't be this one because this is greater than or equal. It says greater. So it must be the second one right here. All right, so we have the manufacturer. Here you don't have a table, guys. You have all the information stated, just in a paragraph. And this is the competitor. This is going to be labeled 1, and this is going to be labeled number 2. How do you label them if he doesn't give you the labeling? Whatever comes first, guys, labeled as number 1, and whatever comes next, labeled as number 2. You perform a study using 14 randomly selected phones from the manufacturer and 16 randomly selected similar phones from its competitor. So would you guys agree with me that N1 is 14 and N2 is 16? The results from the manufacturers have a sample mean of 230. Since this is number 1, your sample mean, usually it's called X bar in chapter 7, but because if you have 2 of them, guys, we're gonna call this X1 bar. 214 feet. Let me just, the results from, have a 230, sorry. With a standard deviation of 26 feet. So it's S1, he's referring to the sample. He didn't say population standard deviation. Unless if he says the population standard deviation, guys, write S. But why S1? Because I have 2 quantities here, 2 sets. The results from the competitor have a sample mean of 216 feet with a sample standard deviation of 32. At alpha equals 0.05, can you support the claim? Assume that the population are normally distributed. So now he's meeting the conditions of the test, and that the population variances are equal. What does it mean for the population variances to be equal? When it comes to pooled, what do you select? Yes or no?
Yes.
Yes, okay. So now HO, guys, HA will be mu1 is greater than mu2. We need to test that the manufacturers is greater range than the competitor. That's the claim. And let's run the test, guys. And that should be it. Stat tests number 3. 2 sample t-test. Now, when would we use data? If he gives you a summary, like set 2 sets, L1 and L2, you put them in L1 and L2, you run data instead of using the summary. But in this question, it's when we do a review next week on Monday, I'll make sure that there is a question, with data, so we can do data sets as well. So X1 bar, guys, it's 230. S1 is 26. N1 is 14. X2 bar is 216. S2 is 32. N2 is 16. And now the alternative sign, guys, just be very careful. Here it is, greater than. Again, before you hit calculate, you choose the sign from the alternative hypothesis. So that's a greater. And then you agree with me, we have to choose yes for pool because it says population variances are equal. Let me just write it down. Means pooled, yes. And this is a 2 sample t-test. All right, and we're almost done. Let me do a draw here. If there is a p-value, guys, well, there is always a p-value. It's going to be on the right because it's a right tail test. Sorry. Straighten this. Takes a little bit time because it's a higher resolution. Okay. So T is 1.3027, which is 3 decimals, so 1.303. And the p-value is 0.1017. And let me put alpha, guys. And do I put this or that? First or second?
First.
All right, I agree. And what's the decision?
Failed to reject.
Man, I feel bad. All of those problems we end up, I feel bad for HO. We haven't been accepting, we haven't been not feeling bad for HO, HA. We haven't been able to reject HO in any of the problems. It just happened, guys. So fail to reject HO. And I think, guys, probably you're tired of hearing this. There is not enough evidence. If you rejected HO, you will start with there is enough evidence because you failed to reject HO at the 0.05 level of significance to support the claim that the manufacturer cordless telephone I'm just copying and pasting the claim, guys. Range is greater than that of its competitor. And that concludes the test, and that's a summary. Perform a 2-sample t-test for the difference between two means, mu1 and mu2, with independent samples when sigma 1 and sigma 2 are unknown. This is the 2-sample t-test.